Hello my dear students, very good morning all of you. In previous lecture we discussed about a 3-alkyl keto effect and effect of polar atom. Today I am going to teach you a stereochemistry in enolization and ketolization. Okay, then as you know what is enol and what is ketone group. Okay, suppose I am taking one example, that is this is a cyclohexanol. Okay, this is the structure of the cyclohexanol. In shear conformation the structure is like this. This is the chair form of the cyclohexanol. Here is equatorial hydrogen and here is a axial hydrogen. In that, suppose by using base, the function of base is abstract the acidic proton. Here is a this axial and here is a equatorial proton. Okay, in which both are acidic in nature, but in case which proton get abstract first, as axial proton is abstracted or here equatorial proton is abstracted. Okay, suppose the here here the carbonyl group. Okay, the carbonyl group is a part of the 6-membered ring. In case of the this example, the carbonyl group is a part of the 6-membered ring, then axial proton is abstracted first. Okay, then axial proton is abstracted first. Now the one question is arise here, why only axial proton is abstracted here? Why not this equatorial proton? Why base abstract this axial proton or axial hydrogen? Why not this equatorial hydrogen? Okay, here is a negative part, then formation of carbonyl group, and here is a enol group. Okay, in which mechanism, like here is equatorial hydrogen and here is a O minus. Now the electrophile is also attack, or in the reversible process the electrophile is also attacked from the equatorial position. So if here is a electrophile, this nucleophilic bond is attack over this electrophile and formation of the, here is a electrophile at equatorial position and here is a electrophile at axial position and hydrogen is at the equatorial position. In means the incoming group is also attacked over this axial side. Okay, but why only this axial hydrogen is abstracted first? Okay, the question is why only this axial hydrogen is abstracted by base? Okay, why not this equatorial hydrogen? Because here is a sigma bonding overlapping between this axial hydrogen, and here this is located very favorably as in pi bonding of this carbonyl group. Okay, and because of this effective overlapping, axial hydrogen is abstracted by this base. Okay, but when the carbonyl group is a part of the 6-membered ring, okay, the carbonyl group is a part of 6-membered ring, then axial hydrogen is abstracted first and then incoming group, that is electrophile, is also attacked from this to the electrophile from the axial position. Okay, now the second one example is acyl cyclohexane. The second one example is acyl cyclohexane. C double bond O CH3. Here is a double bond. Acyl cyclohexane. Cyclohexene. Okay, in which here this carbonyl group is not part of the 6-membered ring. This carbonyl group is not part of the 6-membered ring, means this carbonyl group is not directly attached to the this ring, and then the attacked from this equatorial side. Here the stereoelectronic requirements is not more important or not plays important role in acyl cyclohexene, but steric factor plays an important role in acyl cyclohexane. In case suppose by using the reagent, Grignard's reagent, PH, Mg, Br, in presence of CuI, then 1,4 addition is take place because of this CuI, then pH is directly attacked over here, and then O minus. Okay, then our structure is like, here is a pH, here is double bond, here is O minus, and here is a CH3. Here O minus and pH minus plus MgBr is a plus, because all metals are plus, therefore MgBr plus. Okay, now in next step, okay, there is a reverse process and formation of the carbonyl group. O minus will get again converted into the carbonyl group, and because of the electrophile is H plus, then this attacked from this equatorial side. Then the formation of pH, here is a C double bond O, CH3 and H plus. In chair form, sorry, H, hydrogen. In chair form, the structure is like this. Here is a pH group, and here is C double bond O, CH3 and hydrogen. Okay, just remember one thing, but when the carbonyl group is not directly attached to this cyclic ring, okay, or this benzene ring, then the addition or the electrophile it attacked over the from this equatorial side. But when the carbonyl group is directly attached over to the uh, directly attached to this carbonyl group, this benzene ring is directly attached to the carbonyl group, then axial hydrogen will be removed first. But in case of this acyl cyclohexane, equatorial attack is more preferable. There is a steric factor plays an important role, not a steric electronic factor. Okay, suppose by using Br2, then our structure is like this. Here is C double bond O, acyl group, and here is a Br, and here is a pH. Okay, but why equatorial attack is more preferable in case of this acyl cyclohexane? Because there is a rotation takes place. This carbon and this carbonyl group, there is a rotation may be possible, and due to this rotation, this carbonyl group is parallel over to this CH group. Okay, the rotation takes place because of this carbonyl carbon, and here is this carbon. Okay, there is single bond present, hence rotation is possible, and due to this rotation, this carbonyl group is parallel to this CH group, and because of this, the equatorial hydrogen or incoming group is from this equatorial hydrogen, or less steric requirements is possible here. Okay, you get it? The stereochemistry of enolization and ketolization. Here is a formation of one enol, and here is a formation of again ketone. Okay, hence there is a enolization and ketolization. In last process also there is a formation of one enol and one ketone. Okay, you get this? Okay, then thank you.